Hey students, today's lesson is on adding and subtracting linear expressions. So to start with, let's get this definition written down of a linear expression. It's an algebraic expression in which the exponent of the variable is 1. So the expression has to contain a variable, but that variable will not be taken to a power other than 1. It won't be a squared or a cubed variable. So let's look at some examples. This top row is all examples of linear expressions: negative 4x, 3x plus 5, 5 minus 1/6x. We can see that the variable can be multiplied by something, 3 in this case or 1/6 in this case, but every time that variable is to the first power. Here's examples of nonlinear expressions. So x squared, negative 7x cubed plus x, and x to the 5th plus 1. Anytime there's a power other than 1, it's no longer a linear expression. All of these examples happen to have x. It could be any variable though, y, z, q, whatever you pick. Okay, so let's go ahead and start with modeling. So I'm going to model how to add two linear expressions with algebra tiles. So here I have an expression x minus 2 and an expression 3x plus 8. And I'm going to add them together to make one expression. So I'm going to start by writing these as sums. We're going to kind of get rid of all of the subtraction, and that's going to help us see better what we're doing. So the second expression here is already written as a sum. I'll leave that one as is. But the first one, instead of x minus 2, I'm going to do x plus negative 2. Sometimes when we do this, we kind of put some brackets around the outside to help us see that this is x plus negative 2 plus 3x plus 8. Okay, so make sure you have that rewritten. And then I want you to model these as I model them with the algebra tiles here. So x plus negative 2 is going to look like this: 1x and 2 negatives, just like we did in the activity. And then we're going to add, so that means we're just going to add on some more algebra tiles here to represent 3x plus 8. So 1, 2, 3, and 8 positive counters. Okay, so now I've got all of this stuff. Now I just need to simplify it. So I'm going to combine our like terms. So I'm going to take these x's and put them all together so I can see that in total I have 4 x's. And then I'm going to go ahead and move these over. I'm going to move one positive with each of those negatives because just like when we did integers, we can see that we have some 0 pairs here. So a positive 1 and a negative 1 is a 0 pair. I can cancel that out. I can cancel this out, right? Those are 0 pairs. So what I'm left with is 4x plus 6. So I've added these two expressions, and the sum is 4x plus 6. Now we're going to try a few without using the modeling, with just using what we know about addition. Okay? So I have two expressions again, and again, one of them has subtraction, so I'm going to rewrite it with all addition. So the first one I'll rewrite exactly as it is, negative 4y plus 3, and then the second one I'm going to rewrite as 11y plus negative 5. I should have put this in brackets there. Here we go. Okay, so now we have all addition. We know addition's commutative, so even though we have these brackets and parentheses, we can now kind of ignore those because we know we could do addition in any order we want. So I'm going to group our like terms together. Negative 4y plus 11y. That's my two variable terms. And now I'm going to group my two constant terms together. Plus 3 plus negative 5. Okay, so negative 4y plus 11y is 7y, plus 3 plus negative 5 is negative 2. Now, to put it back in simplest form, I'm going to put it back as subtraction instead of adding a negative. 7y minus 2. That is our simplest form adding of these two linear expressions. The next example is a little bit more complicated because I have to use the distributive property. You can see that there's a 2 outside of this first expression. That means there's 2 of them. We could add negative 7.5z plus 3 plus negative 7.5z plus 3 plus 5z minus 2. But I could also use the distributive property to make that in a little bit of simpler form instead of just adding them. So here I have 2 times negative 7.5z, that's negative 15z, plus 2 times 3 is 6. Okay, so now I've gone ahead and distributed that 2, and then I'm going to rewrite my second expression, and I'm going to go ahead and write it as addition also. So 5z plus negative 2. Okay. Now we have all addition. That's all we have. We've gotten rid of our multiplication. We've gotten rid of our subtraction. So now I can just group my like terms together. Negative 15z plus 5z plus 6 plus negative 2. Negative 15z plus 5z is negative 10z plus 6 plus negative 2 is 4. So negative 10z plus 4 is my sum. All right, let's try a little bit of subtraction. We're going to start with modeling. Just like when we did integers, the difference between modeling addition and modeling subtraction is we're going to start with whatever the first expression is, in this case 5x plus 6, and then instead of adding all of this stuff, the second expression, we're going to take it away. So let me start by modeling 5x plus 6. You go ahead and do the same thing on your paper. 1, 2, 3, 4, 5. And then here's my positive 6. Okay. Now, we need to look at what our subtraction problem tells us to take away. We need to take away a negative x and 6 positive counters. I have the 6 positive counters. I don't have a negative x to take away, right? So I need to add a 0 pair of x's. So look at this. I'm going to add a positive x and a negative x. Okay, this is still 5x plus 6. I haven't done anything yet. I've just added a 0 pair. Now I'm going to take away a negative x and 6 positive counters. Now I've subtracted negative x plus 6, and what I'm left with is 1, 2, 3, 4, 5, 6 x's. So 5x plus 6 minus negative x plus 6 is just 6x. And we showed that with modeling. We're going to do a few examples where we aren't modeling, but just subtracting using what we know about subtraction. The same rules are going to apply with what we did with integers and rational numbers. We're going to change all of our subtraction to adding the opposite. Okay, and I'm going to require, for at least the time being, that everybody do that. Change all subtraction to adding the opposite, because it's really going to help us with simplifying these. So I'm going to start with what's inside the expression. Before I change this subtraction symbol to addition, I'm going to deal with what's inside the parentheses. So I'm going to rewrite this as negative 2z plus 3 minus z plus negative 1. So I change the z minus 1 to z plus negative 1. Now I'm going to change this subtraction sign to addition by, go ahead and write this first expression, 2z plus 3. And instead of subtracting z plus negative 1, I'm going to add the opposite of z plus negative 1, which would be negative z plus positive 1. The opposite of z is negative z. The opposite of negative 1 is positive 1. Now I have all subtraction, or I'm sorry, I have all addition now, so I can go ahead and group these in whatever order I want. So I have negative 2z plus negative z plus 3 plus 1. Negative 3z plus 4. Okay, I had to do a lot of changing subtraction to addition, but once I did that, it was easy to see what the opposites are. So that's an important step. Here I have another subtraction problem. This time I can see that I'm going to have to distribute this 2. Before I do that, though, I'm going to change all of my subtraction to addition. So let me start with what's inside the parentheses. I'm going to have 7y plus 5 minus 2 times 4y plus negative 3. Okay, so now what's inside the parentheses is addition. Now I'm going to change this subtraction sign to addition. Okay, so I have 7y plus 5 plus negative 2 times, and I'm going to leave this the same for now, 4y plus negative 3. I'm leaving this the same for now because I'm going to distribute this negative 2, and that's what's going to change the signs. Okay, so all I did is change this minus 2 to plus negative 2 times whatever's in this bracket. All right, so now I have 7y plus 5 plus negative 2 times 4y is negative 8y plus negative 2 times negative 3 is positive 6. Okay, that was a lot of work to get to this point, but now we're at a sum of terms. Now we're at something we can easily simplify by combining like terms. 7y plus negative 8y plus 5 plus 6 is negative y plus 11. All right. There are quite a few steps on some of these, so go ahead and try the on your own. Change every subtraction to addition, okay? Adding the opposite. And try those, and I'll see you soon.